He's hungry. He's found us. And he's coming! Ding, 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 ding. Ding, 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 ding. Ding, 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 ding.
Scientists studying the inner workings of the planet were astounded to discover a new hidden world deep inside of the Earth. The groundbreaking discovery has challenged decades worth of accepted science about the Earth's solid inner core.
And today we're going to be discussing some of the new discoveries in regards to these relatively large blobs you see right here present inside our planet. The blobs we sometimes refer to as LLSVP. Large low shear velocity provinces. And they're called that because, well, there's sort of a mystery. Basically, inside our planet, somewhere right above the central core, or somewhere inside the mantle, there are several blobs, really large blobs, that seem to possess different density as if they were different objects inside our planet, representing approximately 6% of the entire volume of planet Earth. With all of this discovered many decades ago, by studying various types of S-waves or shear waves, usually caused by various types of earthquakes as they pass through our planet, and as their speed changes according to what's inside the mantle and according to what's inside the core. And through these various investigations and studies, the scientists over time were able to map these structures, discovering that, well, first of all, they are pretty big, but they also seem to be mostly contained in two separate regions of the planet. There is the African LLSVP, that you can sort of see stretches across most of the Western and Central Africa. And then there is the Pacific LLSVP, that goes through most of the Southern Pacific. A new study also discovering that there is a major difference between the two, which potentially suggests different origins as well. But first of all, when they were originally discovered, it was sort of assumed that maybe these are just very massive super plumes. Basically, these really large formations formed by the interaction of the outer core with the mantle itself, possibly produced in a very similar way to what we usually see inside a typical lava lamp. But the plumes produced in a typical lava lamp, and by extension planet Earth, would actually be very different in shape according to various simulations. As a matter of fact, we sort of expect very long, very narrow plumes, as opposed to the shapes observed inside planet Earth. And so it's actually more likely that this has slightly different origin and is very likely something to do with objects or things coming from the surface of the planet. As a matter of fact, as you can see on this map right here, each of the LLSVP structures contains several different superplumes or hotspots on the inside, with the plume itself being several thousand kilometers across and being at least 1,500 kilometers in height. So it's very unlikely to be just a simple plume that you see right here. And so one of the other more likely explanations actually involved the motion of plate tectonics on the planet, and specifically the subduction of various continental and potentially oceanic plates. For example, we know that once in a while our planet has a tendency to produce what's known as supercontinents, with a lot of these supercontinents formed when many of these plates sort of stick together. But when a lot of different plates come together and start interacting, they can often produce what's known as the slab graveyard. Or basically when a lot of plates suddenly converge in a single area, something that we think might have happened approximately 750 million years ago during the existence of supercontinent known as Rodinia. This could hypothetically result in the accumulation of various oceanic slabs all in a single area. And although the high temperatures and pressures would melt some of these slabs, overall this would produce a heavier and denser area compared to the rest of the mantle. Or in other words, all of this could be just extremely old crust from ancient planet Earth, melted and sort of stuck on the bottom of the planet. But there are, I guess, two problems with this particular explanation. One is coming from this recent paper that discovered that there seems to be a relatively major difference between the Pacific and African LLSVP. And the other one is really in regards to the fact that there are two major spots, and they both seem to be relatively massive and relatively large in size. But I guess first, let's talk about these major differences. And so this new analysis using various geodynamic models discovered that, first of all, these two regions seem to have relatively different heights. As a matter of fact, the African LLSVP seems to be at least twice as high as the one in the Pacific. Here, the African one seems to be at least 1,000 kilometers higher, which the authors think is most likely caused by the slightly lesser density compared to the Pacific counterpart. In other words, it sort of suggests that these two blobs potentially have slightly different, or actually very different, composition, which may also suggest possibly different origins. They might not have actually been created in the same way. And on top of this, the African LLSVP seems to be a little bit less stable, which the authors believe might explain why there's a lot more intense volcanism in the regions around the African LLSVP compared to the regions in the Pacific, which then most likely affects how the continents move on the surface of the planet right now. But I guess the other $1 million question here is, so what is that other origin story? How did the other LLSVP come to be? Well, it's in regards to that other study we discussed in a video a few years ago that very likely explains the origin of at least one of these blobs very well. And in this case, it's the story of the formation of the moon. We of course refer to this as the giant impact hypothesis. The idea that approximately 4.5 billion years ago, a relatively large object similar in size to Mars, that we currently refer to as Theia, collided with the early planet Earth, eventually forming the modern planet Earth and of course the moon that we have in our night skies. But it's believed that some of the leftovers from Theia might have actually sunk to the bottom of the planet, probably staying somewhere above the core, forming at least one of these unusual regions. And the fact that it sunk to the bottom and the fact that the density here seems to be different suggests that the fragments from Theia were probably enriched in what's known as iron oxide compared to the rest of the Earth's mantle. And all of this right now seems to match with at least some of the samples we have from the moon and some of the samples from various oceanic islands that seem to be overlying the Pacific LLSVP, which of course suggests that maybe at least one of these, and possibly the Pacific one, was actually created through the giant impact. But the other part, the African LLSVP, might have been created differently, in this case, possibly through the massive amount of subduction during an era of a supercontinent on the planet. But even now, it's still just a hypothesis based on some of the observations and studies we've been doing for the past few decades. So even now, nobody actually knows the true origin of LLSVPs inside our planet, and more importantly, what effects they have on our planet even right now. Nevertheless, this study right here is still pretty interesting, and the study from a few years ago has actually helped us realize how the collision with Theia 4.5 billion years ago might have been extremely important for kickstarting a lot of plate tectonic motion and a lot of mantle motion inside our planet. As a matter of fact, a lot of these effects we're observing on the surface today might have been directly influenced by that Theia collision. But for now, all of this is of course just a hypothesis, and we're not going to know more about this until future studies. On that note, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon by joining channel membership.